Well, we introduced this subject. We will talk about Ethernet technology. The Ethernet technology is a baseband LAN technology. That is a technology that use all the band of frequency of the channel. That is the baseband offered by, for instance, twisted pair, coax cable, fiber, and this technology was proposed by Xerox in the 70s. This technology is based in the access to a shared medium through an algorithm called carrier sense multiplexes with collision detection, CSMA-CD. Still in force for its simplicity and low cost. And these technologies support multiple physical medias. Is a technology that offers very good scalability and is very flexible. And in fact, the same specification has been extended to at the origin to Ethernet and to IEEE 802.3. That is a specification that operates at 10 megabits per second over those medias, that is coaxial cable, UTP, and shielded twisted pair, and fiber cable. And other application of those specification is for 100 megabits per Ethernet. Is a simple LAN specification, also known as fast Ethernet, operating at 100 megabits per second over UTP and fiber, not coaxial. And for instance, for 1000 megabit per second Ethernet, that is a simple LAN specification, also known as gigabit Ethernet, operating at 1 gigabit per second over UTP and fiber cables. In fact, the Ethernet is a very old technology that was developed in 1972 at the Xerox Park, that is the site that Xerox has in Palo Alto Research Center in California, near San Francisco. And this is a drawing that was made by Metcalf, Dr. Robert Metcalf, for a presentation at the National Computer Conference, and contains the original names. That is, in fact, this is the shared media, the coaxial cable, typically called, in fact, the ether, in order to offer a media to the propagation of the signals, of the digital signals. This is called the transceiver. This is the station. This is a node. This is another station. There are several stations that are communicated across shared media, that is this coaxial cable. In any of those stations, we have typically a controller, a communication controller, an interface, and this is a special cable, a special interface called AUI, adaptation universal interface. If I'm not, I don't remember now exactly the name, but is called AUI, And this cable permit the connection of the interface that is plugged into this station with the transceiver. The transceiver adapt the digital signal to the media, in this case, the coaxial cable. And in that way, all the station could listen what is transmitted across the shared media, across the coaxial cable, and if nobody is transmitting, they could transmit a message, a frame, over the shared media. And in that way, all the station could exchange messages that are called frames or Ethernet frames. The Ethernet technologies offers different medium-dependent options or medium-dependent definitions. And in the origins, the first specifications support typically three medias: thick Ethernet, thin Ethernet, and UTP, use unshielded twisted pair, where unshielded twisted pair is in fact star tree topology, where the hub emulates the behavior of a bus. And after the proposal of the UTP, Ethernet proposed later the use of optical fiber cables that permit to transmit the signals further. There were different kinds of notation or terminology to refer to those different medias. We talk about 10 base 5 when we talk about the thick cable, 10 for 10 megabits per second base, because the technology use the baseband of the cable, and 5 because the maximum length of a segment is 500 meters. In the case of thin coaxial cable, where we use, for instance, connectors called BNC, and the terminology used was 10 base 2, 10 for 10 megabits per second base for baseband, and 2 for the maximum length of a segment that was 185 meters. And in the case of the use of twisted pairs, the name of that kind of specification was 10 base T, where 10 is for 10 megabits per second base for baseband, and T for twisted pair. What we need to know is that in the case of 10 base 5 and 10 base 2, we use shared media. In the case of 10 base T or 10 base F for fiber, we use a dedicated media. The dedicated media is because there is a point-to-point link between each station, each node, and a concentrator called hub, or for instance, switch. In the case of using twisted pairs, we use unshielded twisted pairs. Each link has two pairs. one pair to transmit from the station to the network, and another pair to transmit from the network to the station. Then in the case of the use of this media and this kind of concentrators, that is hubs or switches, the hub or switch is an intermediate system that receives typically, for instance, signal, the digital signal in one port, and detect this signal, decode the information from that signal, and retransmit a new digital signal with that information, with that frame, over all other ports of the device. In that way, the device emulate a bus, even if this topology is a star or star tree topology. And in this table, you could see different parameters associated to each of those specifications, those physical specifications. All, in this case, all are specification for 10 megabit per second data rates. The maximum segment size, that is the maximum segment size of a coaxial cable, thin or thick, for a UTP cable, for a fiber cable, is 185 meters in the case of thin coaxial cable, 500 meters in the case of thick coaxial cable, 100 meter for UTP cable, and 2000 meters for fiber, typical multimode fiber. Physical medium in the case of coaxial cable is the coaxial cable has an impedance of 50 ohms. And well, in the case of 10 base T and 10 base FL, we use UTP and optical fiber, typically multimode fibers. And finally, the physical topology, because the logical topology of Ethernet is always a bus. But in the case of a coaxial cable, the physical topology is a bus too, because every node could transmit, could listen and could transmit at any time. And then the behavior of the shared media is a physical bus, a physical bus that permits a logical bus too. In the case of the use of 10 base T and 10 base FL, that is with UTP cables or optical fiber cables, we have a physical topology called star tree, and the hub or the switch emulates a bus from a point of view of a logical topology.
Well, in order to better understand the concepts involved in the Ethernet technologies, we must talk about the topologies. There are two topologies, one at the physical layer, another one at the logical layer or data link layer. In fact, what happens is that we use a physical topology that could be bus, but or could be a star, or could be a star tree topology of connectivity. But in fact, Ethernet uses the concept of a logical topology called bus. That is a topology where all the stations are communicated, are in a group of stations that could exchange frames across what we call collision domain, because every station could transmit and could listen or receive at any time. Later we will talk about the algorithm to access to that bus. But now what is important to understand is the particularly concept associated with two levels of topology, the physical and the logical one. Then the first scenario is several stations or nodes that are connected to a shared media. For instance, typically coaxial cable. It could be a thick or a thin coaxial cable, and in that way, all the stations could exchange digital signals, could listen if the coaxial cable is transmitting any digital signal. Any station could receive what other station is transmitting, and in that way we have only one segment, that is, for instance, a coaxial cable segment, without, in this case, without repeaters. And this is the first scenario. The second scenario is if this segment has the possibility to reach certain distance. For instance, in the case of the thick coaxial cable, this segment could be only a maximum of 500 meters. In the case of thin coaxial cable, this segment could reach a maximum of 185 meters. Then the second scenario is if we need to cover a further distance, we need to transmit signals farther, far away, those 500 meters in the case of a thick coaxial cable, or 185 meters in the case of thin coaxial cable. We need to use what we call repeaters. Then the repeater receives the digital signal, decode it, and with the information bits decoded, will recode another digital signal in order to transmit that digital signal over another segment. The segments could be different. For instance, this could be a thin coaxial cable, this could be a thick coaxial cable, and so on. And in that way, we could reach a bigger distance from one end to the other end of the network. Typically, when we use this topology with several repeaters, there are limitations related with the number of repeaters that we could use in cascade. That is, the maximum distance between one node and another node or another station in this collision domain is restricted, and we will see that that restriction is because there are what we call a maximum collision window or collision time that we support, because we use minimum frame size, and we need that every station in the collision domain detect the possible collision that occur in that bus. Another scenario is when we use physically star topology, for instance, when we use unshielded twisted pair UTP, or we use fiber. And then, in fact, the links between the stations and a concentrator that we call hub, those links are links where, in the case of UTP, we use two pairs, two twisted pairs, one to transmit from the station to the hub, another one to transmit from the hub to the station. In the case of the fiber, we use two fibers, one to transmit from the station to the hub, another one to transmit from the hub to the station. And what the hub perform is a function that transform this star topology into a logical bus topology. And this is achieved by the hub in that way. The hub receives a digital signal over a port, decode that digital signal, and with the bit stream information, recode another digital signal to transmit that bit stream over the other ports. In that way, the hub emulate a bus, but the hub is not in charge of avoiding collisions. Then, typically, a hub is a repeater with several ports, and the hub, in fact, constitute a collision domain, what we call a collision domain. That is a domain of stations that could collide one with other. Yeah, another scenario that is possible is the scenario where we use a physical star tree topology with several hubs. For instance, those are different hubs. For instance, in the 80s and 90s, but perhaps more in the 80s, we use, for instance, a hub per floor in a building, and a hub in order to interconnect all the floor hubs across a central core hub of the building. Then, in this case, these stations could be communicated with, for instance, any of those other stations across a two-level cascade topology constituted by those hubs. What we need to see in this drawing is that, for instance, if this hub in fact is a repeater with several ports, in order to transmit a signal, for instance, from this station to this station, the transmission have to travel across 1, 2, 3 repeating entities, and that is something that need to be taken into account in order to respect the limitations, the minimum and maximum limitations related with those topologies, those physical topologies. And typically, then we have those parameters that we must respect. The first is the minimum frame size at each bit rate. For instance, in the case of 10 and 100 megabit per second, the minimum frame size is 64 bytes, that is 512 bits. And if we calculate with this minimum frame size and this rate, we could calculate, for instance, the time that a station will be transmitting any frame, the minimum time that any station will be transmitting a frame. That is called the collision time window. That is the time window during which collision could be detected. Then after that, we need to respect those maximums in order to avoid, for instance, collisions that couldn't be detected by all the stations, and we need to respect those limitations in order to avoid the loss of power, of signal power, due to, for instance, the propagation phenomena across the different segments. That is, the coaxial cables, or the UTP cables, or the fiber cables.